In this video, we're going to talk about how we can model with linear equations. So we're just going to walk through a few examples. Let's look at the first one. Widget Incorporated introduced a new widget. The cost to develop the widget was $3,900. So this is a fixed cost. And it costs $25 each to manufacture one. So your fixed cost, this is going to be your y-intercept. And then the cost per item is going to be your slope. So if I'm thinking about that cost, I'm going to use C for cost instead of Y. It's going to be $25 for each item plus that $3,900 to create it to begin with. So there's my cost equation. B is asking us to find the total cost to produce 4,525 widgets. So we're going to plug that into our equation for X. 4525 is my X. So cost is going to be 25 times 4525 plus 3,900. And when I plugged that in my calculator, and I did that off screen, I ended up with a lot. $117,025 to produce 4,525 widgets. So there's my total cost. 117,025. So C is saying a total of blank widgets can be produced with $97,500. And now they're giving us the cost and they're asking us to find X. So we have 97,500 is equal to that 25X plus 3,900. So we're going to start by subtracting the 3,900 from both sides. So 97,500 minus 3,900 is 93,600, and that's equal to 25x. Let me move this to the other page so I have more room to write. Give me just a second to readjust this. I lost my 9. So now we're going to divide both sides by 25. And that's going to give us x by itself. And it looks like that would produce 3,744 widgets. Let's look at the next example. It's a tuition example. In 2002, the cost of tuition at a university was $160 per credit hour. In 2006, the tuition had risen to $240 per credit hour. A is asking us to determine a linear equation to represent the cost C of tuition of a function X, which is the number of years since 2000. So we got to be careful here. 2002 is 2 years from 2000. So that's 2 years, and the cost was 160. So notice I'm writing this as ordered pairs. So I'm looking at my ordered pairs as years since 2000. And then I'm looking at cost. So in 2006, it had risen to $240 per credit hour. So 2006 is 6 years from 2000. And then the cost is $240 per credit hour. They're asking us to find an equation. Well, we've got 2 ordered pairs, so we can go through the process that we talked about before. So we're going to have slope, which is y2 minus y1 over x2 minus x1. So we're going to have 240. So that's my y2 minus 160, which is my y1 over x2, which is 6 minus x1. So 240 minus 160 is 80 divided by 4. That's going to give us 20. So now I'm going to use my point slope formula. Y minus y1 equals m times x minus x1. So I'm going to use y minus 160 equals 20 times x minus 2. So the 160 is my x1 and y1. Let's do some fancy math. So we're going to distribute 20x minus 40, add 160 to both sides. So we're going to get y equals 20x plus 120. So there's my cost equation. Cost is equal to 20x plus 120. So what this is telling us, slope, remember, is rise over run. In this case, my rise is in terms of cost, and my run is in terms of time. Because I've got 20 as my slope, 20 is the same thing as 20 over 1. So for every increase in 1 year, so each year, that cost is increasing by $20 per credit hour. That's our interpretation of slope there. B is asking us in the year 2009, how much is the tuition going to be? So we got to think about how many years is that since 2000. That's going to be 9 years since 2000, so that's what I'm plugging in for my x. So I have 20 times 9 plus 120. That's going to be 300. And that's per credit hour. And then C, in the year blank, the tuition will be $480 per credit hour. So they're asking us to find X when the cost is $480. So we're going to set that equation equal to $480. To solve it, we're going to subtract 120. And then we're going to divide by 20. And that's going to give us 18. So that's 18, but this means 18 years since 2000, which means it's going to be 2018 because we would add that together. So in 2018, we would have expected the tuition to be $480 per credit hour. Let's do one more example. A candy cane company has a machine that produces candy canes. The machine produces 102 candy canes in 3 minutes. So our time is 3, and we're going to produce 102 candy canes. So when you're thinking about ordered pairs, if time is one of your variables, it's always going to be X. And in this case, the number of candy canes is going to represent Y. Okay, the reason time is always X is because it's independent of everything else, and X is our independent variable. They tell us in 8 minutes the machine can produce 272 candy canes. We want to find a linear equation that represents the number of candy canes produced in T minutes. So we have two ordered pairs. We're going to start by finding slope. Remember, it's y2 minus y1 over x2 minus x1. So we have 272 minus 102 over 8 minus 3. So this is going to be 170 over 5, which is 34. Okay, remember that's rise over run. So we're thinking about candy canes over time. So that means for this problem that the machine can produce 34 candy canes every minute. I'm going to abbreviate candy cane CC. So now we're going to use y2 minus y1 equals m times x2 minus x1. Substitute in what we know. Oh, just kidding. I am not paying attention to what I'm doing. This is y minus y1 equals m times x minus x1. I'm going to use the 3 102 ordered pair. So it's going to be y minus 102 equals 34 times x minus 3. So let's simplify. Y minus 102 equals 34x minus 34 times 3 is 102. So now I'm going to add 102 to both sides. And we're going to get y is equal to 34x plus 0, which is just y equals 34x. And they want us to use an n here instead, so I'm just going to say n equals 34. And they're asking us to use t instead of x. So in blank minutes, the machine can produce 240 candy canes. Candy canes is our y value, okay, or our n value. So that's what we're going to plug in. And then we're looking for t or x, whichever variable you want to use. I'll use t. So we're going to divide by 34. So t equals 240 divided by 34 is 7.06. So a little over 7 minutes to produce that many candy canes, 240. And then C is asking, how many candy canes can the machine produce in 6 hours? So we got to be careful because all the original time was in minutes. So we got to think about how many minutes is this? Well, we know 6 hours would be 6 and then 60 minutes per hour. So that would be 360 minutes. So that's what we're going to plug in for that X or T, whichever one you're using. I'm going to use that n equals 34t. So n equals 34 times 360. So we're going to produce a lot of candy canes, 12,240 candy canes.